So today we will be taking a look at this 2019 Dodge Challenger. It is at my friend's shop, and he gave me a call, asked me if I wanted to kind of help look over and verify what was going on after some things that they had found and fixed. So it turns out that they had this little guy pay a visit under the hood, and this was the result. Now these are injector connectors, and it's for cylinders 2 and 4. 2 is on the right, 4 is on the left. Number 4, the two wires were touching together. Number 2, only one was chewed through and exposed but not contacting the other. Now here's the shot after the repairs were made to the connectors, adding new replacement pieces, and we were tapped in because the vehicle still had a misfire, and these were the codes that were continuous and would not go away. And so we broke out the scope and decided to see what we could find. Do a key on. Then crank it. Turn it off. Alright, start it up. Shut it off.
Ready, Dick?
Yeah. So we decided to check the circuit by doing a load test from the beginning point of the PCM connector to the ending point of the injector connector on the control wire for the injector duty cycle. And clearly you can see the light bulb turn on, and so the circuit was good. So at this point, we're pretty much gathering our information to pinpoint that the computer has an internal issue from being shorted out with the two wires touching. But my friend had a great question. He asked, why does the data in the computer show that the injector still has a pulse for a duty control? And so I'm going to try to answer that question that my friend had the best way that I can, just from what I'm mentally picturing. So here we've got a shot of a computer. It's actually the same type of computer setup that these Dodges have. And so if we take a look here, this big square chip, that's going to be our main processor. And let's call this little chip here that we have two fake wires going to is going to be an injector control driver, which then will have some wires going to an injector. And so one portion of the computer, you can almost think of this system like the engine computer in the vehicle. Our engine computer will control solenoids, injectors, motors, actuate different components, all on the vehicle. And so it's a computer, wires, and then actuators. And inside the computer on the circuit board, it's no different. We've got a main processor and then connections on the board or through the board to a component that will be commanded and controlled. And so this is what we are looking at, a main computer and then a component that is being controlled. And so on one portion of the main processor, it can tell and verify that there is a circuit problem leaving or outside of the main processor. But another portion of the main processor is actually trying to actuate the injector, and that's why you see some duty cycle attempt or control in data, because it's trying to control it, but another portion of the computer can tell that there is a circuit problem, and it's going to be somewhere post the main processor from the board through the driver, through the board again, through the connector to the actual connector of the injector. That circuit monitoring starts from here and goes out. And so since we checked everything external to the computer, we are going to assume that we've got a problem internally, most likely the injector driver. All right, guys, so I'm back at my shop after basically helping them guys diagnose the Challenger over there. And I told them that I would come back, kind of take a look and see if there might be a possible way of repairing their computer. The ultimate fix would be to, at this point that we've determined that the actual computer is at fault, would be to get a new one, replace it, install it, and perform factory programming. And obviously that would get it back up and running. Now there's also the viable option that I offer and other people can do, is we can source a used one, pull this info, and clone it over to the donor and get one working without having to do programming, and possibly at a lower cost of initial computer purchase. But since either of those two methods, we would kind of have to wait. Me, out of curiosity, told him that let me take a look at the board, see if the injector driver could be located, found, and identified, and even be something that I would be able to replace. So on this particular model, it is simply just a spare unit that I have here, and I have already opened it because I was basically educating myself, playing around, doing some mapping work on it. Now this comes out of a 12 Wrangler 3.6, but I just wanted to see if it would be similar setup as the one that we've got on our 19. And so basically what I did for this one is try to identify which connector has the injectors on it, and then map out from the face here, the pinout, to internal pin, and then see where it goes, see if we can locate an injector driver. Now the way that I went about doing it is, initially I had thought the connector was the other one based off the color. It was the same as the 19. That color had the injectors on it, but I couldn't locate something that was viable. Now, just off experience, looking at this setup with the hardware, I know that these guys here are drivers, they're MOSFETs, and so we have 1, 2, 3, 4, 5, 6. So that type of MOSFET I've seen both for ignition coils and injectors. But being that I only see 6, it's going to be for either the 6 injectors or the 6 coils, and we have something else driving the other, vice versa, that this is not going to be. So that's why I had to try to identify and see what's going on. So, knowing that these are one of those two, I looked up ignition coil pinout, and it's on the same pin that the injectors are on. So I pinned out the coil pin, I think coil number 1, which is actually pin 1, which I think is this first one here on the left. And so that's how I used it. Now let me just get set up and show you. That way, visually, you get an idea. So let's see. So anytime it makes contact with itself, it's going to beep. So there we go. That's the first pin. And so if we now go there, that pin is tied into this MOSFET, which is an ignition coil driver for number 1. So that answers the question as to what these control, but it also helps verify that this is the connector that both coils and injectors are on. And so then now, cylinder number 4 injector is pin 11. So if this is 1, then I'll just count up to the 11th pin and see where that goes. So there's the 11th pin. We go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then, so from here, let's see. This guy here, if we follow that trace, goes there, and then it goes here to this little chip. Now I pinned out the rest of the injectors, and another injector goes to this leg here, and then 2 injectors go to this guy here, and then 2 injectors go to this guy here. So that's 2 times 3, that's 6 injectors. So that tells me that these are the injector drivers. They're easily accessible. I would feel confident in removing this, and in hopes that this is what got burnt up and messed up with the 2 wires touching. So what I'm going to do is use this guy as the sacrificial PCM. I'm going to remove one of these drivers and then open up the computer that we have messed up and swap it over. Now, one thing to point out, if we look here, so we've got for coils 1, 2, 3, 4, 5, 6. We've got 2 empty spots here. This would be 2 more for a V8. And then, if we look here, we've got an empty spot for another driver for injectors. If we had another one here, then we can drive 2 more, and that would be 8 injectors. So I am almost wondering if a V8 computer could be programmed and used in the V6, since all the drivers are there for a 6-cylinder. And obviously a 6-cylinder cannot be programmed to a V8 unless you go ahead and add these hardware components. I'm curious if that could be done, if you're ever in a pinch, but I was just making note to point that out, how the computers are set up. So I'll go ahead and try to remove this guy. We know these are a known good, and then we'll swap it over. Now, one thing to note is the installation orientation. You don't want to mix that up, because I'm sure you can burn something up. Alright, so we've got the other end of the meter on this pin 11, because it's the same on this Challenger 4-cylinder 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then if we look that, it actually goes to, they're a little bit set up different, or not as close, but it ends up over here. So this is going to be the driver for cylinder 4 injector. So here's another shot of the injector driver, but this did not go over well. As you can see here, that the plastic portion of the driver chip is starting to melt. This must have basically maybe cooked itself to the circuit board because it would not budge and it was fighting me. But eventually I did get it off, and here's a shot of that. Cleaned up the circuit board and then was able to attempt to get the new donor driver solder on there. And here's a shot of that. And so now it's time to put it all back together and put it back in the car. All right, we got the computer installed. See, I haven't grabbed the scanner just yet. Let's see what it does. Key on, and we'll start it. Seems to be idling smooth, no check engine. Looks like we might got a fix here. Gonna let it run for a little while. Let me grab a scanner, but so far no miss. Pretty sure we got a good injector control right now. Alright, so turned it off. Let's go ahead and quickly read trouble codes. So no trouble codes stored. That's after we took the computer out, fixed it, and put it back in. So I'd say we are good to go. Successfully repaired the injector driver, and I'll get it all put back together, and we should be good to go.